Mr. Feynman, are you the father of nanotechnology?
Yes, I am.
Can you tell me what nanotechnology is in general?
Well, nanotechnology is the study and manipulation of individual atoms and molecules.
Please tell me more. I'm interested.
Before, it was first invented by myself in 1959. But modern nanotechnology began in 1981, when scientists and engineers were able to see and manipulate individual atoms using a scanning tunneling microscope.
What can it do?
In nanoscience and nanotechnology, atoms and molecules can be seen and controlled. The food we consume, the clothes we wear, the structures and houses we live in, and our own bodies, are all made up of atoms.
But how can we see atoms?
Seeing anything as small as an atom with the naked eye is impossible. With the microscopes you use at your school, it's nearly difficult. But in the early 1980s, nanoscale microscopes were developed.
And how can it contribute to our future?
In a time frame of approximately half a century, nanotechnology has provided the foundation for extraordinary industrial applications and exponential growth.
How can it help our growth?
In the medical field, it has a significant impact on medical devices such as diagnostic biosensors, medication delivery systems, and imaging probes.
And
additionally, nanomaterials are now widely used in the food and cosmetics industries to improve production, packaging, shelf life, and bioavailability.
Thank you for sharing those information, Mr. Feynman. I shall get back to you soon. Nanoelectronics holds significant promise for expanding the abilities of electronics devices while reducing their size, weight, and power requirements. Display screens can be improved by cutting power requirements while lowering the weight and density of displays. One application of nanotechnology in medicine currently being developed involves employing nanoparticles to deliver drugs, heat, light, or other substances to specific types of cells, such as cancer cells. Nanotechnology is improving the efficiency of fuel production from raw petroleum materials through better catalysis. It is also enabling reduced fuel consumption in vehicles and power plants through higher efficiency combustion and decreased friction. Game-changing benefits from the use of nanotechnology-enabled lightweight, high-strength materials would apply to almost any transportation vehicle. Air pollution. Long exposures to high concentrations of nanoparticles brings a number of adverse health effects. Brownian motion and thermal noise mean that parts are constantly flexing and fluctuating in size, much worse than the mechanical tolerances that we rely on in macroscopic engineering. As mechanisms get smaller, the relative amount of interfacial area becomes much larger and surface forces become stronger. The eutectic environment and the feed-through problem. It is envisaged that the operations of man will take place in a completely controlled environment sealed from the outside world. Ethical dilemmas include hazards of nanomaterials, ensuring adequate investment in toxicological and control research, and selecting and implementing controls. The miniature size of nanomaterials and the way their surfaces are modified to increase the ease with which makes them potentially damaging for humans and the environment. UNC Chapel Hill is one of the leaders in research devoted to nanotechnology. These are the things they can benefit us.